Okay, let's take a moment and talk about these. These are again reviews on rates and ratios. And again, our purpose in doing this is just to try and keep and practicing in other skills, even while we're studying in a different concept and content. And if there's things that you don't know in here, then you might be able to pick up some things that'll serve you well in this content area as well. So for number 7, it says Quentin can type 94 words per minute. And it wants to know how long in minutes will it take him to type an essay that has to be 2,500 words long. So there's a number of ways to do this. If you use the ratios, then you could say that he can type 94 words per minute means per 1 minute. And we want to know if he has 2,500 words, how many minutes will it take him? And so to solve it by proportions, you could set up this proportion. A proportion is simply 2 ratios that are set equal. And then to find the answer, you would cross multiply and then divide. So 1 times the 2,500 is just going to be 2,500, and 2,500 divided by 94. Looks like they're rounding this to the nearest, what are they rounding it to? Approximately how long in minutes?
26.5.
Well, officially that would round to 26.6. Since it said approximately, I think you could justify either 26.5 or 27, I guess. Usually when they use the word approximately, we can just estimate.
Oh, okay.
And these are answers are also close together. I think you could defend either 26.5 or 27.
Nice.
So usually when it's estimation, the answers are farther apart. So I don't have the answer key. I don't know what answer they would pick, but I think you could argue for either of those. Most important idea, I guess, is the idea of understanding. I guess the other thing you could say is if we're totally estimating, we could say 94 is close to 100, and 2,500 divided by 100 would be 25. So I'm not sure what answer they would say is the correct one, to be honest with you on this one. Because typically words like estimate or approximate or about how many, these are words that tell us we can estimate, meaning we can kind of round things to easier numbers to use. So if you took 2,500 divided by 100, you could say it's approximately 25 minutes. So unsatisfying as it may be, I'm not sure what answer the answer book would say is the correct one. If you were to see a GED question with an estimation, these answer choices would not be so close together. That's really not a very good question, to be honest with you. I should have read it more carefully before we started this. All right, number 8, how many pages are there in a book that takes a student 7 days to read if he reads an average rate of 25 pages per day? 23 pages per day. Thank you. Anyone have an idea on the answer for that one? You're going to multiply? You want, what's that? You think the answer is D? It take him 100 and, oh, there's 161 pages. My goodness. And how'd so you multiplied 23 times 7. Yep, that would work. The other thing you could say is 23 pages per 1 day. And he's doing 7 days. And we want to know how many pages. And when you cross multiply, you end up multiplying exactly like you said, 23 times 7, dividing by 1, which doesn't do anything. And so 23 times 7 is 161.
You have a second?
Okay, so 161 is a good answer for number 8. Number 9, a bicyclist travels at a rate of 15.5 kilometers per 1 hour for 3.5 hours. How far did he travel? Got any answers on those that you'd like to share, chat, or turn on your mic? Or here in Page? You think C? How'd you get that, Curtis?
I multiplied that
Okay,
by, yeah, but you just can't really do that.
so you multiply 15.5 times 3.5?
Yeah.
Good job. Again, you could set it up as 15.5 kilometers in 1 hour, and we want to know how many kilometers in 3.5 hours. And so when you cross multiply, you end up multiplying exactly like Curtis did, and you would divide by 1, which doesn't change anything. So basically we multiply 15.5 times 3.5, and you are correct. The answer is C. Good job. Okay, any thoughts, questions, concerns about these first 3? Okay, number 10, Alicia can serve 4 customers every 10 minutes. And at this rate, how many customers can she serve per hour? 5? Okay. Anyone else?
24.
24? Anyone else want to put an answer out there? Okay. She can serve 4 customers in 10 minutes. And we want to know how many she can serve in an hour. But this bottom of this fraction is minutes. So how many minutes are in an hour? 60. So we'd put 60 minutes here, and we would multiply this direction and divide by the 10. So you take 60 times 4, divide by 10, and you get 24. Good job, Dakota. She could serve 24. The other way to just think about it without setting up that proportion would be every 10 minutes she can serve 4 customers, and there's 6 10 minutes in an hour. And so every one of those 6 10 minutes, she can serve 4 more people. So 4 in the first 10 minutes, 4 in the second 10 minutes, 4 in the third 10 minutes, and so on.
I had the other way around that. 3 minutes for the 10 minutes, so 4 for 40 minutes, then 5 for 15 minutes.
Okay, gotcha. Okay. All right. Any thoughts, questions, concerns about that one? All right. Number 11, an athlete can perform 20 pull-ups in 15 seconds. I think that's pretty impressive. 20 pull-ups in 15 seconds. I know I couldn't do that. So we're looking for his rate of pull-ups per second. And so we want pull-ups over seconds. And he can do 20 pull-ups in 15 seconds. And if we want to know his rate, that means we want to know number of pull-ups per 1 second. So if you set this up as a ratio and proportion, which you don't have to solve it, you can just logic through it and decide whether you multiply those numbers or divide those numbers. But if you set it up as a proportion, it will tell you whether you multiply or divide those numbers. And so that's the benefit if you set it up as a proportion. I multiply 20 times 1 and I divide by the 15. And so 20 times 1 is 20. So I'm ultimately going to take 20 divided by 15. And they have their answer as a fraction. So this is a good review of the calculator. When I took 20 divided by 15, it gave me a decimal, but these answers are in fraction form. And if I want the calculator to turn this into a fraction for me, I can hit this double arrow key and it turns it into the fraction, 4/3. So A would be the right answer for this one. Any questions on how to set that up or how to use the calculator? Okay, if I hit that double arrow key again, it'll take it back to the decimal. And if you look at the key that's 3 above the 8 key, I can actually turn this into a mixed number as well, 1 1/3. So just good advice. Learning this calculator can be a huge asset, particularly if you struggle with decimals and fractions. This calculator can help you a lot in that area. All
How
right,
did you do the mix number?
okay. Let me move in to show you so you can see the key better. Okay, do you see this key that says X and 10 to the N? If
Oh,
you
yeah.
up
Okay.
it says it has N/D, which is a fraction, double arrow, U N/D. So that will take you back and forth between a fraction and a mixed number. And so since it's in green, I push the second key first and then this key and then enter. And it'll go back and forth between the mixed number and the fraction.
Oh, okay, I see.
So again, this calculator is a pretty useful tool. All right, number 12. A teacher who writes her own exams can write questions at a rate of 3 every 10 minutes. If she wants to write a final that has 50 questions, about how long should she plan to spend writing questions? In minutes. Anybody got an answer for this one? Okay, we can set up a proportion. She can write 3 questions in 10 minutes. And she wants to write 50 questions. And we don't know how many minutes. And so I've got questions over minutes, questions over minutes. Here's what I don't know. And so I cross multiply this way and then divide by that other number. And so I take 10 times 50, which is 500, and then I divide by 3. And that tells you what's missing down here, 166.7. And so the best answer, they've rounded to the nearest minute, would be 167. Questions on that one? That was a little more challenging because you can't, 3 doesn't go into 50 an equal amount of time. So this one's harder to logic through, I think, and maybe easier to go ahead and set up that proportion. Thoughts and questions? All right. Proportions and ratios are a really good skill. You can solve a lot of problems in the real world and on the GED, being solid in ratios and proportions. So good skill that we'll probably keep coming back to quite a bit. Okay, we are moving through our area and perimeter. If you remember, this was the last page that we worked on. Back out of here. Dakota, do you have this packet or access to it? It starts out, the first page said perimeter. The first page says introducing perimeter.
Yeah, I have it.
Have it. Okay, great. So the last page we worked on, and I apologize, I trying to get in the habit of numbering the pages by hand, and I did not do that for this one. We're towards the last quarter of the packet. And so we're ready for this page that looks like this. It says 107 at the bottom, and it has these shapes on it. You can find where we're at. Or if you want to work from the screen, you can. Okay, so if you remember, we've been working with shapes that are not standard shapes. For example, this picture here, this room is like a rectangle with another little piece put on it, right? And this one looks like a rectangle with a piece cut out of it. And so what we've been working on is using our formulas of things like rectangles or other shapes where we either piece together and add some smaller areas to get the total area, or we could imagine taking a piece of paper that's this bigger rectangle size and then cutting away a portion. In other words, subtracting out of the area. And so in some cases, it's clear which way would be easier to add smaller areas or to take away, start with a big area and take away. And other times it's not real, it doesn't really matter. For example, if I wanted to use addition for this problem, I would probably say I have this rectangle in orange, and then I'm going to add to it this small piece. So I would find the area of the orange rectangle. I would find the area of the green rectangle, and then I'd add them together. So why don't we try number one, and we'll do it both ways. We'll do it using adding smaller areas or taking a bigger area and subtracting it. So if we take the two smaller areas and we're going to add them, that means we need to find the area of the orange triangle. And remember, to find the area of a rectangle, that's one of our formulas on our formula sheet. And it's length times width. And we just have to make sure we get the right numbers on here because there's 16, 11, 12, and 15. And so can anyone tell me which two numbers we can use to find the area of the orange rectangle?
16 times 15.
I would agree with the 16. But Robert, the 15 goes this whole length on the right. And so I want to cut it off here. And so Curtis is suggesting 11 would be a better choice for the other number. Do you see that?
Yeah.
Okay. And so to find the area of the rectangle, we're going to take 16 times 11, and we get 176 square feet. And then we got to figure out what is the side lengths of the little green rectangle or square. It's possibly a square. It almost looks like a square. Curtis, you say what? Okay, Curtis says it's 4 by 4.
But that's only on iPad.
Let's see, Dakota, I'm going to mute you, I think. There we go. Robert, I muted you. So when you want to talk, you have to turn yourself back on. I wasn't sure where the background noise was coming from.
Okay. I was going to say there's no dotted line indicating that 4 by 4 is separate from the rectangle above. So I'm assuming that it's a negative 12 by 4 would be the space you'd have to take away from 16
Okay.
times 15.
Well, we're gonna do this by addition right now. We're gonna add the orange rectangle and we're gonna add the area of the green. That makes sense?
Yeah, it does.
Okay, so if you see the entire top orange line is 16, and then at the bottom, it's been broken into 12 and this piece. And so that's why Curtis is saying that one side of this green shape is 4, because 12 plus 4 makes the 16 across the top. And then if we look across the side, the entire thing is 15, and this little piece is 11. And so that would force this orange piece to be 11 and the green piece to be 4. So that 4 plus 11 gives us the 15. Okay, everybody see where I'm getting those numbers? Don't hesitate to ask a question. And so the area, this is actually the green thing is a square. And you can still use length times width because that'll work also. Or the official formula for the area of a square is side squared. And that would be 4 squared, or the area would be 16 of the green square. And so if we wanted then to find the area of the entire room, that would be orange plus green. Orange plus green would be 176 plus 16, or 192.
Oh yeah, Mary, I got the same answer. Either way, the way you're doing it or the subtraction method, subtracting
Oh, yeah.
12 by 4, that's the answer I got, 192.
All right. I didn't realize you were doing it the other way. So yeah,
Sorry about that.
no,
Yeah.
no worries. In fact, we're going to actually was going to do that so that we could see that it is exactly the same. So Robert is saying he took this blue rectangle. Okay, he took like a big piece of the blue paper and then he subtracted out. There's another color here.
Yeah, 12 times 4. I did the length and width for the piece that isn't there, I guess, if it was a big giant square or whatever,
Right.
or
Right. I'm trying
and
to
then
their color
I
pen.
subtracted 48 from 240 and got 192.
Yep. So the way Robert did it is he took the blue big rectangle, he filled in the missing part of the rectangle, and then he says with his scissors, he's going to cut away this red shaded part. And when you take the big rectangle minus the cutaway here, then you get back to this single shape. And so, yes, you should have gotten the same answer. And so you took the area would be what, 16 times 15?
Yeah, 16 times 15
Okay,
equals 240.
it does.
And then the smaller missing area is 12 times 4.
Yep.
Which equals 48.
And then if you take 240 minus 48, lo and behold, everything works as it should.
Right.
Get the same answer. Okay. And
Thanks, Mary.
that's actually the point I was trying to make, Robert. Exactly. You
Okay.
for me. So thank you.
No, that's good. I just learned another way too.
So
To fill in that square, fill in or take the little square away from what's already there, or add it, right? You add the little square to what's there. Okay.
so we took the smaller rectangle and added the square.
Okay.
Took the bigger rectangle and subtracted out this rectangle. And again, it should be the same answer. Those would be 2 different ways. And basically what you want to do is kind of evaluate what seems to be the easiest maybe, or make the most sense to you. And if you remember from last time, from Monday, we did this problem, let me zoom in a little. We did this problem with this pool, and we were trying to find the area of the walkway, just this green shaded part. And I said, you could literally break this up into tiny little rectangles and calculate the area of 4 different rectangles and add them together. Or you can take the entire rectangle and subtract out the pool. And we talked about that it'd be a whole lot easier to do the entire rectangle. That's one calculation. Calculate the area of the pool that's on the inside. That's second calculation, and subtract them. Versus if you do 4 rectangles and add them, you've got 4 calculations before you add them all together. So either way will work. Sometimes, like this problem, would definitely be easier doing subtraction. This problem here, I don't know that there's one way that's, they're both the same amount of calculating. It's just Robert subtracted and we added. That's basically the difference. Okay.
If you're negative or positive.
If you're a negative or a positive person, Curtis adds, that could be. And maybe you see, when you look at the figure, you may see it more easily as adding 2 smaller pieces versus subtracting away. So if you look at number 2, basically it's very similar to number 1. And so what I'd like for you to do is do number 2 and find the area. I don't care whether you divide this up into 2 pieces and add them, or whether you take the entire rectangle, like a piece of paper, and then cut out or subtract this piece. Hopefully there'll be at least people that do it each way, and we'll again see that you should get the same answer. So the thing you need to be careful of is you got to figure out these sides that aren't marked. You're going to have to figure out what they are based on the measurements that are given. So see what you can do for number 2. How you're going to divide it up. Are you doing the big rectangle? Okay, you're going negative. All right, so if you attacked this problem as an addition problem, and I'm using orange and green the same way I used orange and green here, that means you would divide it probably like this, and you'd have a 6 by 12 rectangle, and I got 12 and 6 by 12 plus 9 is 21. And I got the 6 because this piece is 9, just like this one, and 9 plus 6 is 15. And so the area of the orange rectangle would be 12 times 6, or 72. And the area of the green would be 21 times 9. And 21 times 9 is 189. And then if I add 189 plus 72, I get 261. Okay, so that's how you would calculate if you divided it up into two rectangles and you added them. If you are, think more in negative space, I guess, and you thought about a big blue rectangle that you're going to subtract out this red hashed piece. Now my red's not going to work. If you're going to subtract that out, then you would start with the area of the big blue rectangle would be 21 times 15. Which is 315. And then you're going to subtract out this small rectangle, which would be 9 by 6, which is 54. And 315 take away 54, lo and behold, is also 261. So do we have thoughts? Does the adding them together or taking away seem easier? What do you think, Curtis?
Well, I did my first one, the addition, then the second one, the subtraction, so,
Okay, so Curtis says he did one of each.
yeah.
Okay, Linda, do you have one that way that seems easier to you? No? Okay. Any other thoughts? Okay, well, 3 and 4 are a little kind of bring the challenge up a little bit. We've done mainly stuff with rectangles. And now we've got, looks like the front or back of maybe a house or a barn. They give us a hint. And hopefully you can see where the rectangle and the triangle are. Basically, we could take a ruler or just draw it across there, sketch it with your hand. And we have a rectangle with a triangle sitting on top. In this case, it's going to be a whole lot easier to take these two shapes and add them together. And the reason is if you do the big rectangle and then you start subtracting things off, you're going to have to do the big rectangle and then subtract 2 pieces off of it, which I think is going to be harder to calculate than simply finding the area of a rectangle, finding the area of a triangle, and adding them together. Robert, does that answer the area for this number 3?
Yeah, well, that's the answer I got. I did exactly how you just explained it.
To add them together?
Yeah, made the two separate shapes.
I guess we'll see how you did. So remember then that area of a rectangle we're pretty familiar with. Robert, what'd you use for the area of a triangle?
The area of a triangle, I used 21 times 10.
21 times 10. How'd you get the 21 and the 10?
The 21, the base of the house, and then 10 from the top of the triangle, or from the bottom of the triangle to the bottom of the house.
Okay. Well, let's go take one step back. What's the formula for the area of a triangle?
It is 1/2 base height
One
or
half,
base times height.
exactly. The triangle formula is 1/2 base times height. And so when we look at the dimensions of the triangle, the height is, remember, the distance from the tallest peak of the triangle, like we're measuring a mountain, straight down to meet the base. And so the height of this triangle is how much?
9.
9. Okay. And the base of this triangle is going to be this entire length from here over to here,
21.
21. Okay. So for our area of our triangle, we're going to have 1/2 times 21 times 9. And then when we have figured the area of our rectangle, we're going to use 21 and 10. And I use 21 and 10 because I've got 21 here, 10 here. So that's how I got those numbers. And for the triangle, I'm using 21 and 9. That makes sense?
Yeah, or 10. Is it 10.5 divided by 9?
It'd be, if you did 10.5, half of 21 is 10.5, but then you'd multiply by 9.
Oh, yeah, multiply by 9. Okay.
Or again,
So,
if we can use the calculator, if you've got it, 1/2 times 21 times 9 is 94.5.
Oh, yeah. Okay.
Okay. Or if you don't have a calculator that does the fraction, 1/2 is the same as 0.5 times 21 times 9, which is still 94.5. Okay, so that's the area of our triangular piece. And then when we take the area of our rectangular piece, 21 times 10, it'd just be 210. It just adds a 0 to it. And so I would add 210 plus 94.5. And you told me different numbers, but somehow you ended up at the right answer. When I asked you what the height of the triangle was, you said 10.
Oh,
So I'm not sure.
did I say 10? I meant 9.
Okay. Okay, well,
I'm a little bit offset. I think it's my equilibrium or something.
no worries. You said the wrong number, but you got the right answer. So
Yeah.
it works.
that's right.
Okay, make this go
Okay.
to, you push that to make it go to a decimal.
Okay.
Okay. All right, so you were exactly on the right track. And again, if you try to make this into a big rectangle, then you're going to have to subtract out these 2 side squares. And I think this problem would really be easier. It could be done by subtraction, but it's easier to do this problem by addition. So the 304.5 square feet. Thoughts, questions? All right. I wish they hadn't given us the hints because that would have given us more to talk about. But they've given us a hint on number 4 is a rectangle and half a circle. And so you can see that they've measured this bottom distance along the rectangle to this point. And so what they're communicating to us is that's where we should draw our half circle. This problem you can't do by subtraction, really, because, well, I guess you officially could. But again, you're going to be taking a big rectangle and subtracting out half. No, that wouldn't work. You're going to have to do this one by addition. A piece of this piece being our rectangle, which I think we're pretty proficient at this point, but we haven't done a circle in a while. So who remembers what the formula for the area of a circle is, either from memory or from your formula sheet?
3, 6, 14.
3.14 is part of it. Okay, the formula
I times R squared.
I times R squared. So the area of a circle is pi R squared, but we only have half a circle, right? And so we're going to do 1/2 of the pi R squared for our half circle. So the area of, like if I draw a half circle. So the first one means area of the circle is pi R squared. Area of the half circle, we just take pi R squared and basically we're going to divide it by 2. Okay. So if we go to our rectangle, that one's not too bad. The dimensions are right there for us, 14, 18. So that's a pretty quick and easy calculation for us. 252. Now for our half circle and our pi R squared, what does R stand for?
Radius, which is
Radius.
half of the dimension
Which is half
So-
the diameter.
or diameter. Yeah.
Okay. And so radius is this length. You can tell me what that R value is.
To me, it looks like if the half a circle is even with the actual rectangle, looks like it's 14 feet from one end to the other. So half would be 7.
I got 2 good answers of 7 from Paige and another good answer of 7 from you. So that radius is 7. And so now we calculate the area of the half circle by doing pi, which you have a key on your calculator that's a pi key, but don't use it because on the formula sheet, the GED is always going to have you use 3.14. And so that's just a good habit to get into. Times 7 to the second power. And so in your calculator, you can, if you've got this particular calculator, you can do the fraction 1/2 times 3.14 times 7. And the squared key is right next to the left of the 7. And you can type all that in one sitting. And so that area is 76.93. Okay, you could also do 3.14 times 7 squared and then divide it by 2 because taking half of something is dividing it by 2. And you still get the same answer. Okay, so then our complete area would be adding the area of our green rectangle to our orange half circle. And so we take 252 plus 76.93. And I get 328.93
0.93.
square feet. Okay. So there's going to be times like if you saw question 3 or 4 on the GED, those would be reasonable GED questions. They're not going to give you the hint. You have to look at the figure and figure out how to divide it up and then how to find these measurements like the radius and knowing that the height of your triangle is this same distance and so on. It would be very unlikely that you would be given just a straight rectangle and asked, what's the area of this rectangle? It would be more likely to be a figure, what we call a composite figure. And all of these are composite figures. Composite just meaning it's several figures put together. Okay, so the next page has several more. It kind of ups the challenge a little bit. So we're going to talk about these just in general, and then I'm going to give you some time to work on them on your own and see how you can do. And then we'll talk about them. Actually, let's do this. It's 2 o'clock. Let's take a break And then we'll come back, talk about these in general, give you some time to work, and then go through them together. So it's 2. So let's take a break till 2:10. Sheena, are you there?
Yes.
I sent you a message. Did you know you're ready for a progress test?
Oh, yeah.
Okay. Can you open the chat so that I gave you the phone number of who to call to set up your progress test?
Yes, I'll do that right now.
Okay, awesome. Thanks.
You're welcome.
Leonard, we're just starting our break till 2:10. Do you need the sign-in sheet? I just send it to you through the chat if you need it.
I missed you. Me too. Did you just get in? Yeah, late last night. Final week? Yeah. It's really happening. Yo, so much to catch up on. I'm over for a free mani-pedi, yeah?
The phone number you gave me doesn't work.
Yep, it should be 7639. I apologize for that. The same
It's okay.
928-526-7639.
Okay.
Okay, sorry about that.
You're good. What was the phone number again?
Sorry, I didn't hear that.
What was the phone number I was supposed to call again?
Okay, 928
Okay, 928
526
526
7639.
7639. Okay, thank you.
Yep, and Linda should answer.
Okay.
Okay, it is 2:10. Let's take a look. I did some coloring while you were away. I want to just talk through kind of how you would work these problems, and then I want to give you time to do it. So if you look at number 3, it says her house, Carlotta's house sits in the middle of her lot. The lot is shaped like a trapezoid. That's this outside figure is a trapezoid. And except for the house and the driveway, driveway, and house. Her lot is covered with grass, and how many square feet of grass are on the lot? So, can you tell me how you, just in words, how you would find the area of all the green grass that I've colored?
Well, first you got to take into consideration the absence of the house and the driveway from the actual trapezoid. So
Okay,
you do the area of the house, which is 50 times 25,
don't give us all the numbers. We're just talking through it right now. So you take the area of the house,
and then the area of the driveway,
okay?
put those to the side. And then you got to figure out the formula or the area for the trapezoid itself
Right?
and minus the driveway in the house.
Very nice. So in words, the concept is find the area of the trapezoid and subtract out the house and the driveway. And on your formula sheet, I can't see where mine is right now. Here it is. On your formula sheet, we haven't done much with trapezoid, but here it is, trapezoid. It says 1/2 height times B1 plus B2. Okay,
Mary, is that base 1 and base 2?
It
Or is
is.
that?
it's base 1 and base 2. If
so
you remember, a trapezoid has 2 parallel sides and then 2 sides that are not parallel. The parallel sides are the bases. So we would have B1 and B2. And then the height is the distance between B1 and B2. So that would be the height of the trapezoid. And we would subtract out the house and the driveway. This problem would be much, again, addition, using our addition method, you're not going to have much success with this problem, I don't think. This is definitely a subtraction type problem. Okay, so we're just going to talk about each of these in general, and then I'm going to let you go do them. Okay, number 4, the Parks Department wants to put tile around the outside of the circular wading pool. Estimate the number of square feet of tile that will be needed. So in words, we want to find the area of the blue. That's what they're going to tile. In words, what are we going to do to find the area of the blue? Anyone want to speak up and tell me?
Find the circumference of the circle or the diameter
Well, you'd want to find the area of the circle.
area of the circle.
Mhm. And after I find the area of the circle, what would I do?
Find the area of the square.
Very nice. I'd find the area of the square. I'd find the area of the circle, and I would.
Subtract the area of the circle from the area of the
Very
square.
nice. Now, key in, this says estimate. And so when you're estimating like the area of this circle, instead of using 3.14 for pi, if you're going to estimate, you could just use the number 3 because we're not looking for an exact answer. And you may estimate differently. We may get different answers, but as long as we're close to each other, this is just an estimate. So you can start using easier numbers, and using 3 for pi would be an easy way to make that simpler. Okay, but he's got the right concept. We're going to take the square, we're going to subtract the circle. Okay, number 5, he wants to cut a circular disc from a square plate of aluminum. How many square centimeters of surface must be cut away? In other words, we want to know the area of what I've colored in orange. And this problem is really the same almost as number 4, right? We're going to take the area of the square and we're going to subtract out the area of the circle. Now, the only thing that makes number 5 a little more challenging is they gave us the radius of the wading pool. But here, my hint to you is you're going to have to figure out what the radius is on this one. Okay. And then number 6, we've got a rose garden.
Looks like it'd be 7.
And we've got 2 triangular planters. And so we're trying to figure out the area of all the stuff I've shaded green. I didn't shade every single bit because I didn't want to write over the numbers. But in words, how would we find the area of basically the entire garden without these planters?
Subtract the triangles from the area.
Right. Curtis says we're going to subtract the area of the triangles from the area of the rectangle. Okay. So with that, those concepts in place, will you work on each of these problems? I'm going to back out just a little in case you don't have a photocopy at hand, and work on 3, 4, 5, and 6 and see what you get.
What kind of
Your formula of your, you got your formula sheet?
Um,
That's right. Formula of my tropical food. That is one. One plus two. You don't just multiply one. That's a good eight.
Three hundred.
200.
Okay.
So they're gonna do 1/2. 120 plus. That'll give you the area of whole trapezoid. Pretty much.
Yeah, that's what I was wondering. The price for that. Try. Yeah, how much I can get that.
Okay, so that's how to get started on that one. Linda, you doing okay? Okay.
So that's so like I on like this.
Just a second. Okay, let's take a look at these. If you're not quite done, that's okay. But for number 3, we want to find the area of the trapezoid. I'm just going to put area of trap. Remember from your formula sheet, that's 1/2. They put the height first, but you can put the other first. B1 plus B2. So basically we need the height and we need the 2 bases. And so our height is 75 and our bases are the full 120 and the full 80. Okay, now you can plug all that into the calculator at once if you want to. To do that, you'd get your fraction and you'd fill it in. You'd multiply times 75. And then you'd open a parentheses and put 120 plus 80. And it will calculate the whole amount for you. So the area of that whole lot is 7,500. But we need to take out the house and the driveway because there's no grass in the house. And there's no grass on the driveway. And so the area of the house would be the 50 times the 25. And 50 times 25 is 1250. And then we want to find the area of the driveway. That is 9 and 20, which is 180. And so we want to take these 2 values and subtract them out of the 7,500. So we can either take this and subtract that twice, or subtract each of those values, or we can add 1250 plus 180 and get 1430, and then do 7,500 minus 1430. And so I get 6,070 square feet. Anybody agree with me? All right, Curtis agrees with me. Anyone else out there in Zoom land agree with me on that answer?
I agree, but I did I got the perimeter instead of the area for the rectangles.
I got 1690.
1690.
Yeah, so it's half of 75 times 80 plus 120.
No, the 120 plus 80 is in parentheses.
Right.
By order of operations, we have to do that addition first.
Oh,
So
okay.
that'd be 1/2 times 75 times 200. And that's how you get the 7,500.
Okay.
Or you can do like I did and type the whole thing in the calculator and it'll add these first. Okay, but those parentheses are important because they set off that if you only multiply 75 times the 120 and then add 80, that's different and then taking the 75 times the 200. Make sense?
Yeah, it makes sense.
Okay. And then we subtract out our 2 areas here. Okay, any other questions, concerns? Okay, so number 4, we have our tile. So we want to find the area of the square. And that is on our formula sheet S squared, which the side is 20. So it's 20 squared, which is 400. So that's the square. If I was going to tile the entire square, I would need 400 square feet. But I'm not going to tile the whole thing. I'm going to just tile around that circular pool. So the area of the circle, remember, is pi r squared. And since we're estimating, you could do something like say, I'm just going to use 3 for pi to make it easier. Since I'm estimating, they gave us the radius, which oftentimes on the GED, they will almost always give you the diameter so that you have to find the radius. But here they were nice and they gave it to us. And so if you use 3 for pi, excuse me, instead of 3.14, you could take 3 times 7 squared and you'd get 147. If you used 3.14, you'd get 153.86. So it doesn't matter to me which answer you used to get your final answer. I'm more concerned that you understand the process, and that is we're going to have to subtract these two values. So if you just use 3 for pi, you'd subtract off 147 and you'd get 253. If you went ahead and used the more exact value of 153.86 for your circular pool, then you'd end up with 246.
246.14.
Yeah. Okay. And oftentimes when we're tiling, they do more estimates because they leave extra for waste, meaning as you cut tiles, sometimes you break them, or as you cut tiles, the piece you cut off doesn't really fit anywhere else. And so oftentimes 10% is often an amount they use for waste. In fact, we just put tile in our house just last month, and they accounted 10% for waste, so that you know that you have enough tile. So anyway, 253 if you used 3 for pi, 246.14 if you used a more exact value. Again, on the GED, you're going to have A, B, C, D answers to choose from. And let's say it said estimate and you got the more exact answer of 246. When you looked at the answer choices, those answer choices would be far enough away that it would be reasonable to pick out 253 as an estimate. So, all right, any questions on that one? So 5 is pretty much the same, except we've got to find our own radius. And well, I'm not sure I put my center of my circle quite in the center, but we'll assume it's in the center, and it would be half of this 14. So our radius would be 7 again. And so this time we're calculating just this orange edges, what we're going to cut off. And so we need to find the area of the square, which is S squared or side squared.
I got 196.
Yep. 14 squared is 196. And then we're going to subtract off the area of the circle. And since it doesn't say estimate or approximate, let's use a more exact answer. We're going to do pi r squared, and let's do 3.14 this time times 7 squared, which actually is the same as what we just did up here. And that more exact answer is 153.86. 0.86, and I'm going to subtract these two values because I'm only trying to find the edges. And so 196, take away 153.86. I get a value of
42.14. I need to learn how to look at the words better. The estimate.
I sometimes when I read, Robert, I read right over those approximate and estimate words too. So not alone in that. I tend to do the same thing. But even if you calculate the exact answer, when you go to your answer choices to choose your answer, you should still be able to figure out which one is correct. It's just when you estimate or approximate, then the math becomes easier. And that would be most helpful if you're on the, part of the test where you can't use a calculator. Because multiplying by 3.14 by hand is a lot more challenging than just multiplying by 3. So just some things to keep in mind. All right, number 6, we've got this garden and these 2 triangular planters. So we talked about we want to find the area of the rectangle. And then we're going to subtract off the area of the 2 triangles. So our rectangle is 30 by 14. And so 30 times 14 is 420. And then an area of a triangle. I'm just going to find the area of one triangle, and then I'm going to double it. Okay. Now the formula for area of a triangle is 1/2 base times height. And what measurements would I use for my base and my height for my triangles?
Feet. inches,
What did you say? I'm sorry, I missed it.
square feet.
Right, we're gonna use square feet, but what number am I gonna
Oh.
put for base?
Uh,
What'd you say, Belinda? Yep, my base of my triangle is 5. And then what's the height? The height is 4, and that's why they gave us this 4 measurement right here in the middle of
Oh,
the.
okay, that's
So there's our base and our height. And so 5 times 4 is 20, and half of 20 is 10, but I have 2 triangles, right? And so ultimately I have a second triangle, or I have 20 as the area of both triangles put together. And so I'm going to subtract 420, take away the 20 for the triangles. So I think we're at 400. Anybody agree with that answer? Or have concerns about that answer? All right. How are you feeling about these kinds of problems? Easy? Hard? Getting better?
how did you get the 2 after you did the formula for the triangle?
Okay, so the area of one of these triangle planters is 10, but there's 2 planters.
Oh, okay.
So this one is 10 and this one is 10. So then I just multiplied by 10 by 2 to get 20. That's the total of the 2 planters together.
All right, cool. Thanks for explaining that.
No worries. Then I subtracted those to get back to 400.
Cool.
When you ask questions, I know at least you're listening and you're there. So that's it for me too. Okay, we have about 15 minutes left. If you look at the next page, the next page is just kind of a summary review of the area formulas and actually simpler drawings than what you've been working on, but we haven't done much with the parallelogram. We haven't done a whole lot. We've done a little bit with the triangle, and then we've got a trapezoid. And so this will give us practice with just the shapes that we haven't seen much of in the real world. You tend to see more rectangles, triangles, circles than you do parallelograms. So take your formula sheet and match these up with the formulas that are listed. And then find the area of these shapes. And let me see if I can back out just a little. Nope, I can't. So let's just we'll look at 1 through 7. And that'll finish us up. Let me give you about 7 minutes to work these 7 problems, and then we'll talk about them, and that'll finish out the class for today. And if you finish early and you actually have the printout, you can go on to the next page. There's actually 8 at the bottom of this one, and then 9 through 11 on the next page.
Oh, okay, so,
Not just the formula, I want you to put the answer. The answer, oh, this one goes up here.
okay.
This one, I give you one extra. This is the base. That's you do one hand. This later.
And that's just that here's your just your twin fraction. And then it says you, that's like unit number plus a fraction. It gives you the space for the one to do. Okay. Yeah, okay. 1/2 of it, okay.
I'm trying to get that.
Yeah,
on there, and then go.
you can't figure out where you're. Oh, you're all the way there. Okay, see what's blinking? Gotta get over to where here. There you go. You are all the way up here. Okay, so I push down and down and down over here, right?
Can I do this?
What's on your multiply, right?
Okay.
Yeah, you wanna get the answer first.
So this is 7
Equals 57. So 1/2 times 8 1/4 equals 57.
over here. now.
Yep. Good job. Okay, we have just a few minutes left. So let's talk about these. If you didn't quite finish, that's okay. I want to make sure the big thing is they've put in some distractor numbers for you. And I went through and highlighted things you really needed. Number 2's, well, here's the answers for hopefully you're able to match up the formulas. We have a parallelogram. And so we just need to take base times height. And the key is, can you identify that this is the base and this is the height? And so that 8.5 is a distractor. It's that slanted length. And we don't use that. When we measure height, we measure straight up and down. And the height matches up to the base. And so we'd have 11 times 7 or 77. Okay, you don't use the 8.5 at all. If you wanted to find the perimeter of that parallelogram, you would use the 8.5 and the 11 and not the 7. Number 3 is a square. And so the area is s squared or 5 squared. And so you'd get 25 for the square. This is the same darn circle we keep seeing on the previous page, actually. Area is pi r squared. And for the third time, we have the radius as 7. And I think that's that 153.86, isn't it? Okay, that's what I thought. I've kind of got that number memorized now, using it several times. Okay. Because they gave us the radius, so we don't have to worry about changing that number. Okay. Number 5 has lots of distractor numbers in it because the area of a triangle is 1/2 base times height. We need 2 numbers and we've got 4 numbers. And so the base is this line right across that would be sitting on the horizontal, and the height is the measuring like the height of the mountain straight down at 90 degrees to the base. And so we're going to have 1/2 times 14 1/4 times 8. And that may look really yucky until you remember that you can put in a fraction 1/2 times, I can put in 14 1/4 right above the fraction key in green. It says UN/D, and that means a whole number and a fraction. So if I push
Trying to figure out how to do that.
I push the green button and then the
I
fraction,
just converted it to a decimal instead.
and that works too. I was just about to say, we'll look at it that way too. You can do 14, fill in the template with 14 1/4 times 8.
Oh, okay. I don't know how to do that.
That's all right,
But I
but
still got 57 though, when I converted it into a decimal, I got
exactly,
14.25.
exactly. If you know your basic fractions like quarters and halves, you can just do 0.5 times 14.25 times 8, and you get 57. And even if you don't know how to convert 1/4 into a decimal, if you just put in 1/4 fraction, and then you hit that double arrow key down that's above the enter key, it'll even tell you what the decimal equivalent
Oh,
is.
that's what that thing's for.
So there's some various ways this calculator can help you navigate the fractions and the decimals, okay? All right, number of hopefully 6 is easy by now. We are just doing length times width of our rectangle, 35 times 14. And we get 490. And then our number 7, we've got distractor numbers. Again, we need for the area 1/2 times the height times the 2 bases that are added. And so we have to identify which numbers we use. Those are my bases. And just like if I'm measuring the height of a mountain, I don't measure it at a slant like the 10 and the 9.5. I measure it straight up and down like the 9. And so those are the numbers I use, and I ignore the others. Okay. Now to put this in the calculator, again, I can press that fraction key and put in 1/2 in my template times 9. And then I can open parentheses, 7.6 plus 15, close the parentheses. It'll do the order of operations. You have to add this first and then multiply, and it will do it for you. So I got 101.7 for that one.
I got that as well.
Awesome. Nice job.
But instead of using 9, I actually split it in half to 4.5, but I still came out with 101.7.
That's because 1/2, yeah, you just did 1/2 times 9 is 4.5, and then you multiplied 4.5 times whatever this was.
Yeah,
Yeah, that works. That works too.
okay.
I just put it all in the calculator together. But your method, you multiplied these two together, then you added these, and then you multiplied them together, and that will get you the same answer.
Okay, all right, cool.
Nice. All right, we're a few minutes over. Julie should be back next week. She'll pick up here. Hopefully you're starting to feel more comfort with area. And again, we're headed towards volume and 3-dimensional figures. So have an awesome day. If you have any questions for me, I'm happy to stay a few minutes and chat.
I got everything. Thank you, Mary. Have a good day.
You're welcome, you too.
Except for number 8. Number 8 didn't even attempt it.
Oh, actually, I did want to ask about that one as well. What up?
Do you have a question, Leonard?
This is about number 8. I wasn't really sure about that one. Like,
Oh, okay.
what's the base on there? Is it 13 or 10?
The base would be the 10 because the base and the height have to meet at 90 degrees.
Oh, okay.
So that's how you can, whenever you find your height, it meets the base at 90, or in this case, an extension of the base.
All right, I got 30 for that one. I'm not sure if that was
So yeah,
correct.
that'd be right, because 10 times 6 is 60, and you take half of it, and that's 30.
Okay, cool.
So you would be correct on number 8. Good job.
All right, that's all I wanted to ask. Thank you.
Sure. Talk to you later.
Right.
Dakota, I just saw your message. I am answering it right now. You need 40 class hours. Do you want me to check and see how many hours you have?
Yeah.
Okay, let me get there. Just give me a minute. Dakota, remind me of your last name.
Got it.
Okay. Just gotta open a file here. Take a minute. Hours. Okay. Okay, ta-da. Okay, so you just started in February, right?
Yeah.
I have through March, I have 11, a little over 11 hours.
Okay.
Sound about right?
Yeah.
Which classes are you normally taking each week?
I do all of them Monday through Thursday, and I started with the evenings,
Okay,
but now I'm doing the afternoon.
okay. So right now I've got you at 11, a little over 11 hours.
Okay, because I last week Julie said it was 16.
Okay, well, it may be that I'm looking at a sheet that tries to compile everything, and it may be that those last few hours haven't been connected. Or if you had hours this week, this is only through March.
Oh, okay.
So anyway, you're under 20 right now,
Okay.
okay? And then when you get
And then
40, we'll let
for
you know.
the dot form, I usually just push save. Am I supposed to push submit?
Yes, you're supposed to push submit, although your teacher should be, we can look at the Zoom log also to see who may have been there and didn't submit a form. And so we may be missing a few hours in there.
Yeah, because I've been logging on like almost every week, every day.
Okay. When Julie,
And I know
and
I wasn't pushing submit. I was using save.
okay, I know you ended up in the table for this class. I looked at the people who submitted, and you submitted your form today because I can see it.
Yeah, that was prior to me knowing to submit.
Okay. Yeah, maybe could you make a list of the classes that you know you attended, and then we can kind of go through and double check?
Yeah, or I can talk to Julie about it because
Okay.
she's more
Has she been in the classes that you've attended?
yeah.
Okay, then I imagine she can help you work it out, okay?
Okay, thank you, Mary.
You're welcome. Have a great day.
You too. Bye-bye.